Mercury. This small sun-scorched world is the closest planet to our sun and the smallest of the terrestrial planets in the solar system. It formed in the hottest, innermost region of the early solar nebula, which allowed only heavy metals and rocky materials with high melting points to condense into a solid structure. What sets it completely apart is its disproportionately massive metallic core, which makes up roughly 85% of the planet's radius, and leaves it with only a paper-thin outer crust. It experiences extreme temperature swings that plunge from blistering daytime heat to deep freezing cold, due to its lack of a substantial atmosphere to trap thermal energy. It holds a vital place in planetary science because its unusual composition forces astronomers to rethink early solar system history, suggesting that a giant ancient collision may have stripped away its original outer mantle, Venus. Positioned second from the Sun, this brilliant world is often called Earth's twin due to its remarkably similar size, mass, and dense rocky composition. Despite these physical similarities, its evolutionary path diverged drastically, creating a toxic environment choked by a thick, suffocating atmosphere of carbon dioxide and clouds of sulfuric acid. This heavy atmospheric blanket traps solar radiation in a runaway greenhouse effect, generating surface temperatures hot enough to melt lead and making it the hottest planet in the entire solar system. Space agencies have sent numerous robotic explorers to map its hidden surface with radar, revealing a landscape scarred by thousands of ancient and potentially active volcanoes. This hostile world matters profoundly because it serves as a critical warning laboratory for climate science, demonstrating how greenhouse gases can completely alter the habitability of a rocky planet, Earth. Traveling along the third orbit from the Sun, this vibrant blue planet is the largest and most dense of all the terrestrial worlds in our solar system. It formed with an abundance of liquid water and a dynamic, life-sustaining atmosphere containing nitrogen and oxygen, which allowed a complex biosphere to develop over billions of years. It stands completely alone as the only known planet in the universe to possess active plate tectonics, a continuous geological recycling process that shapes continents, generates a strong magnetic shield, and stabilizes the global climate. Decades of satellite observations and space exploration have highlighted how perfectly balanced its systems are to support life. It remains the ultimate baseline for modern astronomy, serving as our primary blueprint when searching the cosmos for habitable alien worlds around distant stars. Mars. Located fourth from the Sun, this cold desert world is the outermost of the rocky planets and is instantly recognizable by its distinct reddish hue. This signature color comes from vast deposits of iron oxide or rust covering its barren and dusty surface. It possesses a thin, unbreathable atmosphere composed mostly of carbon dioxide, but extensive geological evidence reveals that liquid water once flowed across its landscape in the ancient past, carving deep river valleys and filling massive lake basins. Robotic rovers and orbiters have spent decades searching its terrain, discovering buried ice reservoirs and studying giant geological landmarks like the canyon system of Valles Marineris. This planet matters immensely to the future of humanity because its relatively accessible environment and historical similarities to Earth make it the primary target for human exploration and the search for ancient extraterrestrial life.